Here we have a problem where we got water in a storage tank, and then so much is entering the tank, and then so much is leaving the tank. And so it's just going to ask us some different things here. So I just want to mention that F of T is the amount of water entering the tank. And on our graph above, that's our curvy graph. And then G of T is the amount of water leaving the tank. And those are both just like Y equals a number, Y equals a number. Those are the horizontal lines. And then it gives us at T equals that number and that number, and T equals 0. The amount of water in the tank is 5,000. So I got those numbers and I put those on my graph right away. It gave us that information. Now for part A, it just strictly asks how many waters entered the tank in the first 7 hours. Remember, your integral is an accumulator. It'll add up those 7 hours of water filling up for us. And so it just says entering amount. I don't care about how much was already there. I don't care about how much was left. I just concerned with the entering amount, and that is my F of T. So if I integrate between 0 and 7 of that F of T, math 9 that's going to give us the total amount of gallons that entered the tank during the first 7 hours of this problem here. Now it said to the nearest gallon. That's why I went to the nearest gallon. I didn't round to the 3 numbers after the decimal like we usually do. Now part B, little tricky, but we're just kind of really just using the graph right there and a little bit of common sense there. It says, find the time interval in which the amount of water in the tank is decreasing. So think about the amount of water in the tank will be decreasing if the amount leaving the tank is greater than the amount entering the tank. That's what I'm thinking about right there. So if the water is going out quicker than what you're filling it up with, then the amount of water is going to be decreasing right there. So you're looking at where is the G graph greater than the F graph. So you could get this from looking at the graph. Remember, your G graph are the horizontal lines. So see how in between 0 and that 1.617, the G graph is higher up than the F graph there. So that's going to be where it's decreasing. And then over here between the 3 and the 5.076, the G graph is higher than the F graph. So the leaving amount is greater than the entering amount. And then so that means the total amount of water in the tank will be decreasing because it's leaving at a quicker rate than it's coming in. Like at T equals 4, it's leaving the tank at 2,000 gallons per hour, but then it's only entering the tank at like 1,500 gallons per hour. And so the amount of water is going to be decreasing because it's leaving quicker than what it's going in at. So that's what I'm thinking about right there. Where is the amount leaving greater than the amount entering? And there's just where the horizontal lines are higher up on the y-axis than that curvy part right there. So you just mentioned the things, and then we always use the parentheses for the increasing, decreasing intervals. And then since I stressed, since the G is greater than F on those intervals right there. Now letter C is where the most work is going to be involved there. And you got to make sure you're checking all the possible candidates. It wants to know where is the amount of water in the tank the greatest. So when you see that word greatest amount, least amount, what you're using from your blue packet, that's a 3.1 absolute extrema problem. We're about to make an XY chart, and you need to check the endpoints of your interval and any critical numbers. And so that's why what I'm doing here is I'm making an XY chart or a T total amount of water chart. I got to check the endpoints of my intervals. That's in between 0 and 7. So I got those in there. And I need to get the critical numbers. Now, I don't really have an equation on this one where I can like take the derivative, set that equal to 0, and then get this T equals 3. We have to kind of remember how to get a relative max from an actual graph right there. So look at this stuff in blue that I have written down. I got at that T equals 3, the amount of water changes from increasing to decreasing. Now look at the T equals 3. Let me explain that. See how the entering amount is greater than the leaving amount. So in this interval here, the water is going in faster, which means the total amount of water in the tank is increasing up until that point. And then right at 3, the total amount of water in the tank is decreasing. We already talked about the leaving amount was greater than the entering amount. So at the T equals 3 on the other side of it, it changes to decreasing. So if your total amount of water changes from increasing to decreasing, think about when we did our X, Y, Y prime chart. That means like your derivative changes from positive to negative. Your function changes from going up to going down, from increasing to decreasing. That's going to be a relative max right there. Right here, the water changes from decreasing to increasing. but that would be like a relative min. And since the problem is just asking me where the amount of water intake the greatest, I don't care about the relative min. I'm gonna find the relative max. That's gonna be like our critical point. And then we gotta check, is it the absolute max by plugging it into our XY chart over here. All right, so I thought that was pretty tricky there, but we just gotta get exposed to that and think about the graph a little bit. And then here, when we're filling the stuff in, the T equals 0, they told us there is initially 5,000 gallons of water in the tank. So I just fill that in automatically. And then what you got to take into account all the time on these total problems, you got to take into account three things: what was already there, how much flowed into the tank, and how much was flowing out of the tank. And so when I'm going between 0 and 3, I started with the 5 grand. And then when you integrate the F of T, that'll give you how much water entered the tank in between the first 3 hours. And when you subtract out the G of T, that will give you the amount that was taken out in the first 3 hours. But see, the G of T in between 0 and 3 was the 250 right there. Now that 250 needs to be inside that integral when you do your math 9, because it's not just 250 one time, it's 250 for each of those first 3 hours right there. So if you put it inside that integral, it'll do that for the first 3 hours. Think about if you were to straight up integrate this, you get 250T, right? And if you plug in the 3, plug in the 0, you will get 250 times 3. So it's just like you're doing 250 gallons per hour for 3 hours right there. But if you put all that in the integral, so I would just type it in math 9, I would type in my F of T function minus the 250, and then that you should be able to obtain that number right there. Now for this part here, this was a little bit different. You could approach the same way. You could go from 5,000, the integral from 0 to 7 minus, but see, when you go to minus your G of T between 0 and 7, you have two different functions right here. And so I kind of use what we found in part A. So I said, okay, the initial amount we started with was 5,000. And then in part A, we already figured out in the first 7 hours, that's how much total water entered the tank. So I added that in. So far there's like 1,364 gallons of water into that tank, but also in those first 7 hours, water was leaving the tank that we need to subtract out. So let's talk about a few different ways of how you can get this G of this 8750 number right there. You could integrate the 250 plus the integral of 2000, and then do this one between 0 and 3, do this one between 3 and 7, add those up. That'll get you to 8750. Here's what I was thinking there, right? I was thinking we're losing water at a rate of 250 gallons per hour for 3 hours. So I did 250 times 3. That gave me a total of 750 gallons was lost in the first 3 hours. And then the next several hours, the next 4 hours, we're losing rate at a rate of 2,000 gallons per hour. So I said, okay, it's 2,000 gallons per hour for those 4 hours. That gave me the 8,000. And when you add those up, that's where I'm getting that 8750 number right there. Another way you can get that 8750 is you're integrating G of T in between 0 and 7. You know your number representation of your integral is the area, all right? And now G of T, ignore the curvy part. G of T is just the horizontal line. So if you do the area of that horizontal line between that horizontal line and the x-axis, that's a rectangle right there. If you do the area of that rectangle, and then you draw in another rectangle right here, this would represent the integral between 3 and 7. So if you do this area, this is 3 times 250, you get the same thing. This area here is going to be 4 times the 2,000, you get the same thing right there. So there's a few different ways you could go about that, just whatever works in your brain. I think it's good to just discuss all of them, just kind of make some sense out of that. But then that gives you this number right here. And then say they want to know what time. And so the lowest Y value, the lowest amount of water is going to be at the lowest Y, I'm sorry, it says the greatest. So the greatest Y value is at 5127, and that's at time T equals 3. So you got to list the time and also that. Now in those problems, this is all of your work. The fact that you're checking the endpoints in the critical numbers, they'll have on the rubric, if you're not checking all candidates, you're not going to receive full credit there. So if the answer happened to be at an endpoint, and then you weren't checking that critical number, you may have gotten lucky and gotten that right answer. But if you're not checking all candidates like that, they're not going to give you full credit right there. So just that process, that 3.1 absolute extrema process, where you're just making an XY chart, checking the endpoints and the critical numbers, that's your work on there. Where on a relative max or a relative min problem, you would have to justify it to max since your function changed from, the derivative changed from positive to negative or negative to positive right there. Honey mustard